I'm gonna assume that this is rolling. I had a little issue again, this time with my internet connection, but I think we're good. So, welcome everybody. And I'm Todd Mariana, Deep Grooves Mastering, opcode 66. And this is the channel where cool things happen. So tonight, instead of music and instead of video mixing, I'm gonna just do the video with a little text overlay. So, this is gonna be covering how to wind coils for the Presto 1D cutter head, as well as just what I use as far as tooling and what I have in this part of my workshop. Excuse me again. It's not really anything I've shown to a lot of people, so consider yourselves lucky, I guess. I don't know. Or at least consider yourselves welcomed into a part of my life that I usually don't share. So I'm going to move the microphone here and come over there. Got a new microphone, so I'm no longer wearing a lavalier, and I'm hoping that it's going to give me better audio fidelity for doing this stuff. So do let me know in the comments if it's too loud or too soft. I will try to make adjustments, but I think it's okay right now. So, oh boy, there's a lot of stuff on the table. I'm going to try to break it down as to what's all here. Might be easier for me to just pull the camera off first here and sort of go through some stuff. So over here we've got a bunch of enameled wire of various gauges. That's actually not my full collection, that's just some of it. Back we've got my coil winding machine. Excuse me, my jeweler's mill. So this is what I use to put normal rounded enamel wire in, and what comes out the other side is flattened. So flattened enamel wire is easier to wind very tightly on coils. So a lot of pro stereo cutter heads will use flattened enamel wire for that reason. Make a very magnified coil. Whoops. What I'm trying to show you here is that this is a little example of some. So this is some that I have flattened. I have a bunch more. I tried different gauges and stuff, and also flattening to different thicknesses, and used to do this machine by hand, but now I have it such that drill here. That drill will work the mechanism for me, and not only work the mechanism, but it will also spool. So if I attach a couple of pulley belts back there, rubber band, this mechanism will also spool as well as flatten the wire simultaneously. When running from power drill, it allows me to have a really consistent thickness to the wire, which you can't really get when you wind it by hand. So a bunch of files, a tool that I use all the time, which is my X-Acto, a little tray full of a bunch of little things. So bits and pieces of stuff that I use for various projects or R&D or whatever, handy little bits of things or material that I can use again. So just have those here. Also like a whole bunch of little tiny Allen wrenches. Definitely something you should have is alcohol. Tool block. This was made for me by Chris Grabowski. Rad. It's indispensable, really. I've always used it. It's perfect for all of my little tools like screwdrivers and pin vices and tweezers and scissors and little solder pump and everything. Little tray back here of some additional tools and also bits and bobs. Some more keys here, magnet, thread gauge, some feelers back here, a lighter. So as it turns out, you can use on some of the really delicate, high gauge, small diameter. And FYI, I make that mistake sometimes. I say small or large gauge when I really mean the diameter, because it's inverse, of course. The larger the diameter, the smaller the gauge, and vice versa. With the large gauge, small diameter stuff, you can use a lighter to carefully burn some of the enamel off of the ends instead of using a razor blade. So if you hold it and you just expose the part that you want to burn, you can burn away just a little bit, and that's very handy. So like that, I've got these guys, which are a bunch of winding rods. So we'll kind of get to that in a minute, but those are how I can wind all sorts of different shapes and types of coils. So those are for different types of cutter heads. We've got here the actual winding machine itself, and this guy, it came with this in the back, which is what holds the spool, and there's a little pulley wheel up here and another pulley block down here. So you'll see me set that up in a little bit, and that's really about it. It's got a whole mechanism, like this part of the thing, and this over here, and a bunch of pieces that I took off that are sitting elsewhere right now. What all those do, as well as this thing back here, is allow you to set up for different gauges of wire and have this thing be able to go back and forth automatically, supposedly. So you can sort of, there's a little gauge down here, which is hard to see, but suffice it to say, little gauge, and you can sort of adjust that. And what you're really doing is changing where one wheel connects with this wheel, so it turns another one like that, and you're basically turning that motion into a turning of this guy. And then you can set these, which are stops, so you can have this thing go turn, turn, and have this thing sort of do your arrange each one of the turns for you automatically, quote unquote. So it doesn't work perfect. It's not like a digitally controlled winding machine, which would actually work a lot better, and you could probably get very consistent coils, and those turns would be perfectly spaced. But with this kind of a machine, which is something that you'll see on eBay, really not going to get that. You'll get close, and so oops, I just party fouled. I spilled my beer. I'll have to clean that up. So that's really only useful for big coils. The kind of coils that I make, typically for cutter heads or whatever, are small, and they'll pack themselves, right? They'll actually spool themselves, just like a garden hose will. If you've got a garden hose sort of thing, it will sort of spool itself. But again, since we're dealing with such a narrow bobbin that we're going to be winding on, like this action would just never work. Like you'd have to put your stops it'd have to be all stops basically. And so what's the point? So I don't really use the automated. I will put this where it needs to be, but manually, but then pretty much leave it. And then if I need to do some spooling, that's where these guys come in. So I use dental tools, right? And a variety of different dental tools. This one is actually only used for applying the resin. So it's got a bunch of the resin on it. It's pretty gnarly, but it's a perfect shape really for sort of dripping some of this stuff on. This is polyurethane resin. Good luck trying to find this anymore because you can't buy it. It's just the environmental laws everywhere. You can't, at least in the United States, you can't buy this impregnating insulating resin anymore. So, you know, that stuff you have to bake. And I modified a whatchamacallit. I'm gonna put this back on. Modified toaster oven, and key, really, the secret there is that you have to evacuate moisture as you're baking the coils with this stuff. So that stuff will never dry on its own in a room temperature. It will literally never ever dry. So you actually have to bake it sort of like silk screening ink, the old school stuff, or paints, I should say. So that stuff, you know, again, you have to bake. I don't like to use it anymore. So most of the coils that I make, I do an alternate method. I'll get to that in a second. If I do use this stuff, I don't use the super glue first. So the trick that I showed everybody when we made a speaker, the little dab, the tiniest little bit of super glue, I don't do. I will use these scissors, which probably has some beer on it now. In fact, speaking of which, I'm going to just mop that up real quick. So for any of the coils that I would actually bake with resin, I would first seal them by taking a very small strip of heat shrink like this. So I would take my scissors, right, and I would cut a really thin piece of heat shrink. And that is what I would use to essentially put a little, put it like a little seal, if you will, around the coil, right? Something's making a noise. Okay, that stopped. Sounded like a little bell or something. So this is, what I would use, and then I would actually use my heat shrink gun to, shrink that around the outer edge, the outer part of the coil. Of course, there's no wire on here, but you sort of get the idea. And then, lessening out. Before that, so as I'm winding the coil, within the last, however many turns, maybe the last quarter or so, last third of the number of turns that you're going to put on the coil, you would start to drizzle, and just a little bit, doesn't take much. So get your tool out, dip it into your resin, drizzle a little bit onto the windings as you're going around. And once you get some in, as you continue to wind, it will impregnate, not only go in, but also be within all of the turns that you put on top of that. And so it doesn't take much. That little bit, like I say, will do it. You don't have to really put any more on afterwards. In fact, you might wipe a little off and then use the heat shrink as a little wrap. That will keep it all in place. And then take it and put it into your coil oven. So again, mine is, can't pull it out right now, but it's a modified toaster oven. And what I've done is I made sure that the front, the door can be propped open, and I've installed a series of fans. Right, so the door is open. There's a series of fans. Those fans are pulling air out, so pulling moisture out as it's evaporating, and that allows for the glues to actually dry appropriately. So, all right, that would be how I do this type of coil. Also, too, I did a little tool, drew a little tool, 3D printed it. These are great for epoxy, actually. So you can make yourself little spreading tools, not only for resin, but primarily for epoxy or super glue. And that helps out a lot. And then, like I was saying, when I wind a coil, I will typically use one of these dental tools to help me guide the wire like that, or maybe like this. So as wire is coming off the spool, I can guide it with this guy left or right by turning it and pulling it. I can also, as I'm doing turns, use this wedge, this thin sort of very long butter knife, I don't know what to call it, to also guide or push a line in turns as I'm doing a coil. That sort of thing is not so important with the 1Ds, but like, again, with a professional cutter head drive coil where you're aligning flattened wire, you're doing that turn by turn, and you are definitely aligning every turn perfect. Sometimes you need to see the back of, so the little mirror, the classic dentist's mirror, is sometimes handy. Whoops. For that purpose, just to see the back. What else? Oh yeah. So this guy, you can see my really cheap 2x4 stand. So that was made before I really had much tooling at all. I could do a better job now, but who cares? This came with this thing, so this was like a USB microscope, cheap, from eBay, maybe $20 or something with the stand. I removed it from its, I think it came with like a plastic square base or something, or metal square base. Removed it from that, and I implanted it into the top of this 2x4 with just drilling a hole into it. And I can pull that up, maybe you can see that. Yeah. So, fairly simple, not super complex, just a stand. So that this microscope thing I can just move it like this. I can position it right over a coil that I'm working on and focus it in, and it can show up on a small, I bought like a very small portable little TV, sort of very small screen. You could also, I guess, use a iPad or something like that. So I have a small screen that I have set up right next to me, my right, when I do that sort of work. So I can see, and then also too, I'm usually wearing some sort of either these guys with the highest magnification, or something like these, like a 3x readers, not a 1x or 2x, but like a 3x. But also too, this thing in and of itself is, how I'm really seeing the fine detail to do the turn-by-turn alignments for something very small, like the drive coils. The other things, like feedback coils, I'm not going to show you that stuff. And in fact, I don't do them on here. Like, I made my own winding rigs to do feedback coils and experimental phono pickup coils as well. So that stuff I really would rather not show you, but suffice to say, this is not my only winding rig. I actually made some of my own, and you can make your own too. It's not really particularly tough. Like I was saying before, I actually disabled a lot of the things, a lot of the features on here. So this, and also this thing is really big. It's made to be able to have a supporting rod on both sides. So sort of like a metal lathe, where it's got like the actual chuck and the spindle chuck, and then the tailstock. This thing can support a coil on both sides. You can wind massive coils, I don't do that kind of work, so I really should have bought the other kind. So you'll see on eBay, there's another style of these things, which looks essentially like a old school pencil sharpener. So if you remember, you're old enough back in the day, what the turn crank handle pencil sharpeners looked like, that's probably better for doing cutter head work, because it's smaller. All you really need is something that turns and doesn't have run out, so it turns and keeps the coil on an axis, so it's not wobbling around as it's turning. That's important, because if your coil is sort of flopping around, you're not going to get you're going to get concentric winds, right? You're not going to get perfect circular winds. You're going to get concentric winds. Kind of like if you don't start tapping a hole perfectly parallel with the actual hole. If it's a little askew, then your threads will come out concentric. Same thing. So, again, the style that's like a pencil sharpener that's much cheaper than this one is totally fine, because all you really need is, again, the rotating axis that is, nice. Here, part of my belt is coming apart. I will explain this in a second, what this is. Never mind all that. And you need a turn count, which is handy. I mean, you don't need it per se, but man, it would be handy. You could simply mark your spindle here, or mark the coil, and count your turns that way. But that would be laborious, and you would mess up here or there. So that wouldn't be great. The other thing that I did with mine, other than disabling the automatic spooling mechanism, is that I added this motor right here. So I bought a sewing machine motor. This was only a couple of, $20, $25 with shipping, maybe, on eBay, I think. I used to, a long time ago, many years ago, get everything off of eBay. I don't anymore, but yeah. So again, very cheap. It was easy to take it apart and add a reverse mechanism to it. So FYI, you could do that, which I did. So that's what that switch is. And it's just changing some of the wiring on the inside so that the starter coil can go one way or the other, because that's how this works. There's two coils in there. And it's, again, it's your basic sewing machine motor. It actually came with this belt. It would have been better to put it on a reduction, but that's okay. I don't care. I've gotten used to working the pedal. So it also came with this pedal and some extra brushes, So this guy, in addition to that mod, I also, I 3D printed and added this little crank right here. So this allows me to gently go forward and backwards if I need to, or also more easily if I've got a bad turn and I need to back out, back up. It helps me with that, and I'll show you how to do that. You have to not only turn the crank, but also turn the spool that your wire is on simultaneously, and you can rewind a turn or two that didn't come out exactly right. Boy, this tripod is just going to be the death of me. I need to get a new one because it sucks. I really hate it. Jesus. Jeebus. Okay, so, this guy is the pedal for that. You can see that's how that works. So I'm going to put it back down on the floor where it normally lives. So I'm actuating it with my foot, obviously, which allows me to be hands-free with the rest of the operation of this guy. I should say, which allows me to use my hands, and the foot is controlling the speed and the movement here. So this is the turn count, again, with the friggin' here. Probably easier. So this is the turn count right here. See, this guy right back here is hundreds. This is, ones. So as this goes fully around once, this will move over one tick. So you can see on here it's labeled 1, 2, 3, 5. Unfortunately, I mostly go the opposite direction to this guy, so it's a little inconvenient. You can loosen this up. Whoops. I need two hands to actually do that. But you can set this back to 0 and screw it, tighten it back down. And so that's something you would do to restart every coil. I'm going to turn this guy out of the way. So it is not blocking me. Oh, and by the way, everybody, thank you if you are joining me now on Twitch. Thank you if you're joining me after the fact. YouTube, please do subscribe to my channel on YouTube. That would be awesome. That would really help. And continue to follow this series, because after tonight, after I wind these coils, I will tomorrow or the next day start to do the actual rebuild process put it all back together and tune it. And that's the stuff, that's the real secrets that you want to see. Because this crap, winding coils, once you know how to do it and get the tooling, it's really not a big deal. You know, it's like really not a big deal once you get the hang of it and get the tooling and know what to do. So I'm giving everybody a shortcut here is to say these things are good. This works. This doesn't. Back to sealing the coils. I don't really use this impregnating resin anymore. What I do is the little trick of a little bit of super glue to lock the end of the coil into place so it doesn't unravel. That's it. I'm not trying to cover the entire thing, just a little bit. Sort of, again, locked the end of it into place. And then probably be good. Outside of that, I will take it into my garage and then actually seal it using epoxy. I don't do that in my living area, especially not around my animals, because it is toxic to breathe in. You want good ventilation, and yeah, it just smells horrible. So I do that elsewhere, but I use a slow drying epoxy, and I will change the position of it so it doesn't like sort of well up with glue. I also don't use a tremendous amount. You don't need a lot. I can't stress that enough. You just need a bit to cover the outside to keep it from unraveling. That's all that stuff does. Serve no other purpose than to just keep it from unwinding. The slow drying epoxies will typically also be resistant to heat, right? So that's what you want, is an epoxy that's heat resistant. Also a clear epoxy, like no additives or anything. So this is how I originally was making my Presto winding rods. So there's a screw-on collar, yeah, there you go, with the screw in it. So a set screw would go onto this part. So I'd put the coil bobbin onto there. I would put this guy on. I would screw that into place. That would lock the bobbin into place. I would take this, right, and put it into here. So this is basically the shape of the winding rod that this machine came with. What it came with was really just a single rod that can go across to here. And I think actually it's in multiple parts. Either way, yeah, I think it is actually. It's in multiple pieces. So, you know, but it looks like that. So you stick it into that end, like so. Right? And, yeah. So, like I was saying before, you don't want a lot of play, but a little is fine. It doesn't, you know, again, these don't have to be perfect. They really don't. I think a lot of people think that at least in the 1Ds or whatever, in the mono heads, that the magic comes from the coils themselves. And in some respects they do, but they don't have to be works of art. It's really the rest of the engineering that makes the head work and work well. So what I changed things to is slightly more simplified version of that. It's going to be a screw that is tapered at the end. You can see that. I will take the bobbins. So I made these bobbins in an earlier stream, and you can sort of see, like right there, there's a hole. So that's where we're going to stick the wire through, and that will be the start of the coil. And we take this screw with the tapered top, put it through like that, screw it into the hole in the end, like that. Super genius, right? And we put it in here, and we wind onto it. Now, there's a little bit more to it than that. So I'm going to have to get set up first, and then we'll circle back to this. But that's essentially how that works. This is the one for 5C, and you can see it's got a form in the center which represents that sort of the middle of the flattened donut, right? The 5C coil has is sort of an elongated circular shape, like a piece of calamari. And so what I've done is I've made it so that I can, unscrew that screw. And so that screw actually holds one of these circular plates in place. And so I can set the exact width that I want for this coil. I can lock it into place with this screw. I can never get the angle right. Okay. And I will wind onto that. It's a little bit more complex than that. You have to put down something slippy so that once you're done, you can actually sort of slide this off. So I will start with a strip of tin foil, just a little piece of tin foil, a little strip that will go in there, and that will be the start of it. I will wind onto that piece of tin foil so that, again, once I'm done, I can unscrew that screw. I can take off the first plate, and then I can use the back plate to slide that coil off, and it will actually slide off if it's on something like a little piece of tin foil. Otherwise, if you wind straight onto plastic, you'll start to unravel the first turns as you try to take it off, and you'll ruin your coil. So you got to put something on it, but you also got to use something extremely thin and, again, sort of slippy. So tinfoil works great. The other thing is you have to start to work some ties in. So you actually have to, on your first couple of turns, put a couple of pieces of thread, sewing thread in a very specific way, such that once you're done winding this, you can knot those off. So tie them off on each end of the elongated circle. And you don't have to do it super perfect, because those are just temporary, the first ties. Once you get the coil off and you remove the tin foil, then you can go and use thread and do really tight permanent ties. So you'll take the original tie off and you'll put on a really tight one. And how you can do that is with a pair of tweezers, right? So you can use tweezers to help you, like a surgeon. Literally, it's almost the same sort of way that a surgeon will do a suture, except the trick to this is, and here's the trick, if you put a little tiny bit of wood glue on you make the first knot and you put a little wood glue on it, and then you go to make this, and then tighten it real good, let it sit for a second. That wood glue, because it's so sort of sticky and thick, it will hold that knot for you tight. And then you go to make the second knot tight, and what you're left with is a very tight little tiny tie. And it was only held in place because, you can't make the first knot and then, have your finger hold down on that and make the second one, right? You only have two hands anyways. So even with tweezers, so you tie into a little tiny bit of wood glue, and that will hold it tight for you. And then you can do the second tie, right? And once you got two ties, you clip any of the little remaining pieces of thread off. So it's just a little tiny tie, right? And you take that whole coil that now has two very tight ties on it and nothing else. It's just no bobbin or anything. And you dip that into the resin and then bake it, right? Or you can epoxy it at that point. Doesn't matter. Either way works. Really doesn't matter. It just depends on what your client wants, right? But this is the best way that I have sorted out to make that style of coil. Sure that there are better or different ways. Whether they're better or not, who knows? It doesn't really matter. I get coils made that are, look just like the originals. And so that's my methodology for doing those. So without further ado, we will dive right in. So with mine, I got to sort of hold this nut on the back, and I can put the arrow where I want it and now tighten the nut. And now that thing is zeroed and actually tightened. What I'm going to do is load up the wire that we're going to use into the spooler. So I will try to get this out of the way and see if we can get it so that everybody can see what I'm gonna do. So I'm gonna load the wire onto this guy back here, the spool, and then I'm gonna run it down here. There's a little wheel on this guy, so it's a little pulley block. Then up here, so there's another pulley wheel right here. And then there are two more pulley wheels over here, this thing. So there's one in back, going up front. And so that's a lot of pulley wheels, right? Well, it's not really doing a speed reduction because those are all sort of the same size wheel for the most part. What it's really doing is when you, like, I'm sure everybody learned this in physics class, if you were to put a rope on something really heavy and try to pull that thing, like, it's a lot, you have to apply a lot of force. If you were to take a longer rope and put it around a tree and then pull on that thing, it takes less force if you are using sort of a fulcrum, a pivot point, right? So once you add enough pivot points, what you're doing is you're allowing yourself to pull on that wire, but not really like tug it, right? You're pulling very gently on it from the spool. So as you're winding, it's not going to make the spool like unravel really quickly or anything. So what you do is you unscrew this little guy right here, and that allows this thing to move. This is a little, how can I say, there's a, right there, there's a little, like a dead center, right, if you will, right? A little pointed rod, and that goes into this hole. And so what I'm going to do is, unscrew this. And again, I mean, everybody thinks that this is like the big secret. It's not. The streams that are coming up, those are the big secret. So everybody that really wants to learn this stuff, please watch the upcoming streams, because with respect to the Presto cutter heads, everything I've done and shown so far, it's relatively pedestrian stuff like that. I mean, it's relatively sort of obvious if you do some basic research. What's not obvious is how to actually tune those heads appropriately. And so that's why I've been giving the breakdown of the physics of it, because that's going to be really important when I go and show you how to not just assemble, but correctly adjust everything, right? Because you can put it all together and it's going to not have the amount of drive that it could have if you actually adjust the parts appropriately. So that's really super important. I can't stress that enough. So what you got to do is put the wire on in a way in which that it's going to unravel this way, right? So it's coming off the spool going towards the wall, basically. So what I did was I 3D printed a few inserts, which I don't know if you can really see, but all that is just a little piece of 3D printed plastic, same as what's in here, right? Just matches the diameter of the hole of this, generally of all spools, most spools, and then has a smaller hole so that I can just put it into here. So the client asked for 16 ohm on this, and sort of remember, I have some notes on how to make those, but I sort of don't believe them, but we'll find out what's going on here. Okay. I would be able to do this much better if I'm not having the tripod in the way. So this, how can I say, there's a little kink. So I'm just rewinding it a little bit because of that little kink in the roll. Okay, now I've got that kink out. As much as I can. And so what we're going to do is go down first to this guy down here. So it's not just going around a pivot, but like the length of each of the things, the rope, whatever, on each side of that pivot will determine sort of the effect. Then we're going to go up to this guy. So normally I have this back a little bit further. Oops. I cleaned my table earlier, and so I have things a bit rearranged. Just to sort of set up for doing this. So let me adjust stuff for, whoops. Let's not do that. So you can turn this left and right. Didn't mean to pop the grommets on that guy. It just being held in place by two rubber grommets. And then go down around the back pulley, or you don't have to if you don't want to. That's what I just did. Ugh, now I've got no room for me. Oops. So again, sort of review. Coming off that way, going down onto this pulley block down here, coming up onto the pulley up there, coming back down onto the back wheel, coming around it to the top of this wheel, right? And now what I'm going to do is, I should have already had, I think I explained this in the prior stream on making your own DIY speaker. So it's really handy to have when you're doing coil work, masking tape. So what I'm going to do is just tape that in place onto the rod right there. There's a supportive rod for this whole mechanism, or this whole machine. It goes across. And it's really handy to wrap enamel wire around it, the placeholder. So I just did that, and I taped it in place. What I'm going to do is cut a bunch of pieces of tape. I'm going to move this camera to a slightly better place, hopefully. Maybe not. Let's see what happens. I kind of need to sit here too. So you guys can see the business end of everything, which is really the most important view at this point. Nothing, I've gone over everything else. Everything that I'm going to be doing from this point forward is going to be right here, basically, in this frame view. And again, if you are joining me here on Twitch, thank you. I really appreciate it. Thank you for your interest in my work. And please do support me by subscribing on YouTube, and definitely send me even just $5 on PayPal. A small donation would be greatly appreciated. Any donations will go towards tooling, things like you see right now, or supplies, or even possibly going towards an actual machine or something. And if you want, I can cite you by name and know what your money's going towards. If you just want to be anonymous, that works too. But it would be super helpful to get a little support, because I will continue this stream with the 1D here and finish it off, and maybe also some of the 5C, but definitely all of the 1D. But then after that, you guys want to see more of the real secret sauce, like the BLDC platter motor or some of my other R&D work. You guys are going to have to help me get to where I can show you that stuff. So here we go. I just cut a bunch of little pieces of masking tape, different sizes, so a couple different thicknesses of strips, and then smaller pieces, and then a couple of big pieces. You never know what you're going to need. A lot of different sizes helps, though. Show you what's up with that in a second here. So, like I was saying, you got to start these guys. Oops. I made a bunch, and that it's in a prior stream. You can totally look that up on YouTube. It's posted. One of them wasn't the best, so I marked it. It's slightly off as far as dimensions. These are all pretty well perfect. They all have that little starter hole in them. So this guy's got one there. This guy's got one. When you do those, I do that on a drill press. You want to make sure that you, man, light is never where I need it. You want to make sure that you start the hole like this one is, which maybe you'll be able to see, maybe not. There you go. That hole is very close to, there you go. That hole is very close to the inner wall of this bobbin. You want that because that's, if it starts higher up and then you're winding, the wire is going to have to go down to meet with the inner shaft. And then as you wind further layers, it's going to cause further layers to have sort of a distortion to their pattern of the windings, right? So to avoid that, make that hole as close to the inner wall as you can. That way, the first turn is starting pretty much right on top of the inner shaft, and then subsequent turns won't be knocked. Have this sort of as you're going as the coil as you're winding around, you'll get this sort of turn, right? It'll be like this in the pattern of the turns for that particular row. And you won't, no amount of pushing over will fix that because there's literally a piece of wire there, right? If the hole is further away from the inner shaft wall. So, okay. This is going to be hard to do because of the legs of the... I'm going to try to adjust the stupid tripod so that I can actually be where I need to be. Okay. I think that'll be good. Cool. Now I can move my chair over. We'll put this right about there. And again, if I'm doing like the Pro putter head with flat enameled wire, which would be like this kind of stuff. You might be able to see that, but it is definitely flat. It's like ribbon. But it started round. It started as regular wire, just like this stuff. I just put it in my jeweler's mill. It comes out like this. It only comes out like this, though, because I put the work into that jeweler's mill. If you try to turn by hand, you'll, again, like as you're turning that crank, you'll inevitably turn it at different speeds each rotation, and that will affect the thickness. And also if you have a very large delta in speed, so as you're turning around and you catch some momentum and it goes really fast at the bottom of that turn, that really fast will equate to a little dog leg in the wire. So if you want to avoid that and have perfectly straight wire of uniform width, you have to attach a motor to your jeweler's mill. So that's a little hint right there. Okay, so basically what we need to do is, what I'm going to do is, since this wire has been sitting for a minute, the end of it is a little rough. It's been bent a number of times, and actually I think it has a knot in it or something right there. To see. So I'm going to just trim the end. I'm not really concerned with wasting a bit of this. I'm going to start fresh, right? So I'm going to pull that tape off, and I'm going to retape the fresh end so that we have nice wire. I'm not starting with some sort of crappy wire, because you know the ends of the leads from the coil, the start and the end of the coil wire, you know, is a little delicate already, and so you don't want those breaking before you do the install. And so you definitely don't want to start with a piece of wire that's sort of degraded. Actually, I'm going to pull a little bit more off because there's a lot of bends in that. So, okay. If you're doing a pro head, sometimes it's impossible on those style of coils. They don't have a hole on, you know, what you're winding onto, and so sometimes it's impossible to know what is. Man, this thing will not ever focus on what I want. Sometimes it's impossible to know which lead is the start and which is the end of that coil. And that's important if you are trying to maintain polarity. With these heads, you know, I make these the way I make them every single time. And I matched what I saw from an original Presto head. So I'm pretty sure that I've got the polarity right. But, you know, with these mono heads, if it's not moving in the direction that you want for positive versus negative excursion, it's very easy to change the connection. You know, it's not so easy in a pro head situation. And also when you have feedback involved, you absolutely have to know the polarity of everything in a channel. Otherwise, if you apply feedback inversely, you'll get self-oscillation and a feedback, and it will burn out the drive coil. So definitely you need to know. So the point I'm trying to make is with a coil like this, it's easy to tell the start and the end. Sometimes, though, it's not. So you'll have to mark one of these. So sometimes when I'm starting a coil like that, I will take the initial bit of lead and I will put like a little slip knot in it or something like that so that I know this is the beginning of the coil. This is the start. Because that information, in combination with the direction in which you are winding the turns, will determine the polarity of the magnetic field that the coil will generate given a signal that is going positive versus going negative. That's AC, right? So, you know, push, pull. The push will always be, you know, one polarity. If this is wound in a certain way, and the pull, the opposite polarity. But again, you can only know on some coils if you actually mark the lead. Another thing you can do is put a little paint or use, you know, a die like a Sharpie, right? A marker, and you can mark that bit of lead. I usually have a Sharpie up here, but mine ran out. So, I got one. Hold on. This is a circuit board marker. Good enough though for doing etching. So you could take this, you know, lead, any part of it here. I'll just mark it like that. Now you know, like the black lead, the one that has a darker appearance, is the start of the coil. So again, for these, that's not as important because I can tell what the start is, given the fact that you can easily see which lead is coming out of the hole versus which is coming out of the end of the outside of the coil. So, you know, again, I don't need to do any of that. So that was just a demonstration for you guys. I'm going to cut that part off. More especially because now I have to thread that through one of these bobbins. So I'm just going to pick one sort of at random. Doesn't really matter. And I'm going to say, okay, that's the hole right there. Right by my finger. Of course. See, there it is. So the easiest thing to do here is to just take some of this wire out and just make like a little a very small L shape in the end. And there you go. And so that I'm going to stick into this hole. I'm going to grab some readers. Right, cool. Now I can actually see what's up. So I just made like a little crook. I'm gonna insert and then turn right when it's by the hole, and it will just sort of thread itself through that hole. Probably didn't see that because I was looking at the thing and not the screen. So let me do that again so that you guys can see what I'm doing. So I just reformed that into the shape of a sort of an L. Not to be perfect or anything as long as it's curved. I'm going to take that, insert it into the bobbin close to where that hole is, and I'm going to turn it such that it pokes right. Oops. That's not the hole. That was the other side. Sometimes when you drill these out, the tip, man, this thing just will not focus. The tip of the drill will touch the other wall. That's what I was trying to push it through. It wasn't actually a hole. It was just a marking. So that's what I did. I just sort of got that thing close. This is just not going to focus where I want it to focus. Come on, camera. Whatever. But there. I got it close to the hole. And then right when it was there, I sort of turned. So it's like this. And so I just sort of turned it. So now it's right going into the hole. And then once it's in, I just sort of push it through. Once it's pushed through, you can just grab it. Right. And now we've got it. And it's, this bobbin is threaded onto this piece of wire. Now, if you wanted to be super fancy and sort of douchebaggy, what you could do right now, and this is something I figured out a long time ago, and I sort of posted on the trolls that I knew how to do it, and I didn't explain it to anybody. So here, I'll explain how to do it right now. So if you want to take this a step further, you could do the same thing and thread on another bobbin. And when you're winding the one that would be in my hand, you're winding it such that the enameled wire is coming through this other bobbin. So once you're finished with this one, finished winding it, you can then pull it off, put this one onto the rod, and wind it. And so then you could have these two wound onto a single continuous piece of wire and not have any solder in between, not have to have these, the leads connected in between with solder, which is what, I typically do. Again, that's a little over the top. But you can do that. You could totally put this one, let me just demonstrate it real quick. I can do that little trick again where I take this and make an L in it, and I'm going to go and put it into this hole. So there's somebody that, somebody out there, and you know who you are, that wanted a bunch of information from me and got some of it. This is one thing I never showed you. There's actually a lot of things I never showed you, but let's just leave it at that. So now that this is on here, and more importantly, the other one is threaded through already too, I could put this guy, I could now mount it onto this winding rod, and as I'm winding, thread it through this thing. So you could put this in between, like this, if you wanted to, or back here in between the these wheels, and let it sort of run through right there. Let me again just keep this into place. Show you guys what I'm talking about. Okay, I really hate this tripod. Boy. So I have the normal wire. Okay, I'm gonna just take this off. Good. Okay. Hagadunga. You know Breakfast Club. Might know what that scene is. Yeah, it's a guy at a water fountain. So you can have this guy threaded through the wire and sitting back behind one of these wheels, and it will thread through and just stay back there. The wheel will hold it in place. And then once you're done, you can pull, with this coil, you pull it off, and then you can pull this guy through the thread and have as much, length as you want in between, and then wind the other one. And now when you go and do the final assembly, you don't have to, again, connect those two leads, because the coils are wired in series in these heads, not in parallel, they're in series. Okay, so the input goes into the start of one coil and then comes out of the end of it and then goes into the end of the other one and then comes out front, and so blah blah blah. It's again, these are in series, right? And these guys are set up so that again, like you could do it like this, or you could just solder the leads together. It doesn't matter. So, okay, where am I going with this? So I'm going to take off the other one. I'm going to just do this guy real quick, and I'm going to show you how to wind it and seal it. And like I said, I'm going to take it to my garage and actually do the epoxy. So that's going to not happen in this stream. I'm not going to do that, but I will do everything else up to that point. Boy, oh boy. Fighting me every step of the way. I think that should be out of the way. Good enough view. And you saw the rest of the setup. We're good on this with respect to that. Okay. Now I just need one of them. And again, I'm probably gonna just bump the camera. I am probably going to go ahead and it's funny, I keep looking at this monitor thinking that it's out of focus, but it's because I'm wearing readers. Okay. I'm going to snip some of this end again because I just, mucked it up by showing you guys all of that. So I'm going to pull some through again. Right? I'm going to use a fresh piece of tape because, as you'll find out, masking tape is really sensitive to dampness, right? So if you have any moisture, sweat, or anything from your hands transferred to a piece of masking tape, it will no longer function. And so that's something to keep in mind. Okay, so grab this guy randomly. Just grab one of them. Put my L in the end by just taking a little bit and then bend, like it's sticking between my fingers, and then I just bend it over my thumb. And now I've got a nice L in the end. Of course, you can't see, but it's there. This. It just popped through, so now I'm going to grab it and pull it through. As I'm explaining things, I think that I made a mistake in explaining something in a prior video, so I might have to do an update. But that's okay. We're all human, and part of this is me trying to explain things live, unscripted, and I don't, I'm not perfect at this yet. I'm getting better, but I'm not perfect. So, what I just did was there was some slack, in the line here, right, as I was doing all of that. So, I just went back here and turned to this guy by hand manually to rewind the wheel. Right now, the way that this thing works, I'll pull it off to explain it, of course. The way that this guy works is in back there's this screw, and that screw has a plate on it, and the plate attaches to the spring. And so as you turn the screw one direction, you pull that plate back, and it puts more tension on the spring. Other way, it puts less tension on. So the more tension you have on this spring, the more tension this entire arm, because this is on that spring, all right? So if you can see, is on that spring. So the more tension on the spring, the more tension on this, the more tension on this wheel right here, and that means the more tension on here. So it's gonna not just, if I pulled on this, it wouldn't just unravel. As you see, it's got a braking system, if you will. So that's what that's all about. So definitely for different gauges, like you're gonna want to adjust that braking speed. Basically, yeah. I'm really ruining and lamenting extending the other segment on this tripod. The legs have multiple segments, and I normally have the bottom ones in, and I raise the camera up the top part of the tripod, which seems to work better. So this is just fighting me a lot. Apologize for that. So now we've got this thing sort of set up. It's almost ready to go. I explained to you the tension mechanism for the spool. Having the wire nice and sort of as straight as you can. Golly gee. What I mean by that is, everything's sort of in line. Here's this mechanism. Here's this. Right up here, and then down there, the block, right, is positioned so that it's in line and on the spool. And what I was trying to do was just pull this actually over a little bit further. So now we're pretty much all in line with that guy. And of course, this is just the dumbest. Okay, now you can actually see. There's the pulley block there. Why I was trying to pull this over is because though it's coming off the spool right now, right there, we want the center of the spool really to be in line with, these things, right? So that's what I'm going to do right now is get the center of this pretty much to line up, and then put this thing down there. What's nice about this guy, this pulley block down here, is this wheel moves, right? So it's going to help sort of align things as we go. And then I just, this thing can move, so I just moved it so that it's in line with those guys, right? And that's in line there. And now we're looking pretty good. Now, final thing is, this is not exactly in line with that. You can see that this guy is a little bit to the left. So what I'm going to do is move this guy so that it's easier to see. So the center of the coil right here be in line with that should be in line with the center of that. You can see it's just slightly off. Move it over just a little bit. As long as you've got the wheels lined up, especially this one is the most important, but it's best to have all of them in line, because then you just have less unintentional tension, basically, as you're winding, and these things really operate the way that they're supposed to. But again, this one's most important. Have the center of it be in line with the center of this, and that means as you're spooling, it will naturally actually do that left and right movement to get a nice alignment to your on the turns in each row, or I should say in each layer of the coil. So now that I've got all that set up and aligned and everything, back on tripod. Hopefully you guys actually saw everything. Yeah, the very helpful piece of information on the wall there. to electrical engineers, that is, you know, the equivalent sort of your periodic table of elements or something, right? Everybody's got one around somewhere. Or your chord book for a guitar, your guitar grimoire for a guitarist. Okay, so now that that's all set up, what we're going to do real quick is handle this, because what you don't want happening, again, like I showed in my prior video where we made a speaker, you don't want this thing to be flopping all around, because inevitably it'll catch on something and break, or you'll just keep putting bends in it and you'll just degrade the wire to the point where it wants to snap. So you very gently, and I do mean very gently, wind it around your winding rod to keep it into place. What I typically do is wind it into sort of one band, and then I will take the little end piece that's left and sort of put it off on its own, away from the main band, and then put a small piece of tape on that, so that when I go to untape this, I'm just untaping a section that's just covering the end of that. So let me take this guy off. Everyone wants to come on. Just sort of show you what I was talking about here. So I did most of the turns right there in one band, and then I spiraled off, and just the end of the beginning of this coil lead is what's underneath the tape. So when I go to pull this tape off, it's only a small section of this lead will be under the tape. And that's important, because otherwise, if you do that over this main band and you go and pull it off, sometimes you can do exactly what we're talking about, especially with thinner wire. You can snap that lead as you're pulling the tape off accidentally. Another thing that can happen is, it's nice to have a little bit of play here, because sometimes this form will slip as you're winding, and if it slips, then the same thing can happen. You can sever the beginning of the coil right there. It sucks to get all the way through a coil and have the beginning of it unusable, right? It's a waste of time and resources. So we are completely ready and set up. I'm going to wind out this coil, and again, I'm not really going to be manually guiding it. It's going to guide itself, because that is so thin. I'm not going to be moving this guy back here or anything. Just going to let it wind up by itself, and once it's fully wound, I will get this end of it to line up with the beginning. I will put just the tiniest amount of super glue, and I'll probably dab a little bit of it off. And then I'll wait till it sets. Once it sets, I will cut the end of it, the lead. I will pull this guy so that it doesn't just unspool, and I will tape it down here. Then I will very carefully pull the rod off and remove, the tape, and remove the coil, and straighten out the leads and trim them so that they're the same length, just for convenience sake. And like I said, this guy will go into the garage, and I will epoxy it with the other one. And once the glue has dried, the epoxy has dried, then I will actually be able to install those. Oops. Man, that thing is just driving me nuts. So I apologize that you're not probably going to get the best angle here. Let me try to get this a little better. I do need to leave room for myself, though. In fact, I'm wondering if maybe the other way is probably best. Let's do that. I had a production assistant. Well, that's probably the best it's going to get, and that doesn't leave me a lot of room here to work, so that's going to be interesting. It's really going to be inconvenient, but that's okay. Pull my pedal over. Try not to activate it as I'm doing that. I'm going to get a little tearing paper ready. I'm going to top up some super glue when I need to do that. So a little trick here when you need to spread something like glue in a really specific place is to take a little piece of a strip of paper that you've torn off of a sheet, or twist the end, and you can make yourself a makeshift paintbrush, if you will. Right? So now I can dip this in a little bit of something and I can use it to spread. I can also use it to sop something up, right? So I can blot with it as well. So I'm gonna get a couple of little things ready real quick for me to blot with. Throw some things away that are sort of hot right now, like and water. Pieces of masking tape. Okay. To get the glue ready as well. Same stuff. Harbor Freight, industrial strength super glue. It's dries quickly. It's very liquidy. It works great. Doesn't leave a lot of super glues will leave after it dries like this sort of white ghost layer, if you will. Because when it dries, it outgasses and it will sort of stain some of the surface around where you had applied it. This stuff doesn't do that as much. So again, I can use this manual crank over here. I can use the pedal, which is what I'm about to use. And I'm gonna make sure that this guy is tightened correctly, and because I do want a certain number of turns. And okay. Well, that was a little fast, but you can see right now, maybe, that thing is actually, the wire's going left and right by itself. And it's doing that pretty consistently, you know. As it gets to the outside, I should say, as we get to the outer layers, that will start to not be as pretty without intervention of some kind. But, you know, that's how it will come out by itself. Another thing too, by the way, it's generally good to, as you're winding this, and I didn't because I forgot while I'm doing it on camera, but even with the tension on this thing from the spring, sometimes it's not enough. And so sometimes I like to actually have my finger on this guy and provide additional attention just to make sure that that thing is winding really tight, because if it doesn't wind tight, then you're not going to get the number of turns on there in total that you're looking for, right? So you really need to, if you don't have enough tension on there, then it won't do that nice left and right action, but also too, like I was saying, you won't get the number of turns that you need. So I just saw that it was getting stuck on one side. If I want to, for a second, you know, if I want to, I can now back out. And how I'm going to do that is I will manually spool this wheel at the same time as turning the crank right over there. So I will, instead of winding it, I will unwind it, right? And wind it back onto the spool. So this is unwinding the coil, and then back here I am turning it such that I am winding that back onto the coil, or back onto the spool. And I'm not releasing the tension that I have already built up on the coil that way. Right? So if you get into a little pickle, like you just saw, where it wasn't really winding real equally and you wanted to go and fix those turns, that's how you can go ahead and do that. Right? So that's how you can rewind back up. As you can see, this thing's getting pretty full. We have already gone 100 and... So this is, you can see Um, and actually, oh wow, yeah, I think we've put on as many as we need. I wasn't paying attention, so we've actually gone past 200. So that would be 100 right there. That would be 200. We're at 210, 20, 30. So that's actually more turns, I think, than this particular coil wants to be. So, you know, there's only certain gauges of wire. The next gauge down would be a different style of head. So this is supposed to be 16 ohms. The next one down would be 8 ohms, and that's AC impedance. And then the next one down would be 4 ohms AC impedance, which would be 2.7 ohms DC resistance. And those are those get hot. You know, those can do a lot of excursion, but will get hot. And once they get hot, they won't do a lot of excursion. So, you know, I would say you're better off with an 8 ohm AC or a 16 ohm AC arrangement for these guys. Again, I pretty much, I think for these, it's supposed to be about 190. So, you know, that's okay. I can just make both of these what they are right here, and it might be just a little bit higher. Also, too, this one's just an example, so I've got other empty bobbins. I can do those, you know, separately. This will also allow for a nice amount of, because again, like with the other gauges and the other impedances, you really fill up the coil. So you don't have a lot of space here for your wrapping. This gives me a little extra space for the wrapping, which is nice. So what I'm going to do is just sort of, or not wrapping, I'm going to be putting epoxy on it. I almost kind of want to, I mean, like, yeah, it's already going to be past what it should be for the client, I think. I'm tempted to just take it to 250. You know, my obsessive compulsion says I should do that, but what I should really probably do is rewind it to maybe 210, 220. And then, like I said, I'll have a nice amount of space for the epoxy. And actually, I'm going to leave it there. So that'll be 100, 200, 10, 20, 30, 230 turns. Again, I haven't made a lot of these in this particular ohm rating. Everybody wanted either 4 or 8, and mostly 8. So, and also it's been a while, and my notes on this are a little sketchy. So, on this particular one, so because again, I didn't make a lot of these. So I'm going to measure this once it's off, and I'm going to estimate it whether it's going to be right once I put it in. If it's not, then I will make another one. I have to make another one anyway, but I will possibly make 2 more. We'll see. So like I was saying before, I'm going to turn this now so that it is aligned with the start hole, which is right there. So that's the beginning of it right there. And turn it a little bit past such that it's now flat at that point, right? Being pulled back. And you guys can see that. So now I've overshot just slightly at the beginning of the coil so that way this is pulled flat against the curved outside. That way I can put just a little drop of glue right here, the tiniest bit, and this will be held nicely that way. Like I was saying before, this is just sort of a little tiniest little tiny bit, such that I can just hold that coil in place and take it and do the actual epoxying on it elsewhere and not have it unravel, but also not use a lot of this stuff, because as super glue gets hot, and I mentioned this in a prior video, it will outgas, and that is toxic, and you don't want to breathe that in. So I don't want to use a lot. And also, it should be noted that this will actually get covered by the epoxy. So it's not like it's just going to be hanging out exposed. It will actually get blanketed by epoxy. Again, you don't want to use a whole lot, because that's not the point. We're not sealing it with this. We're just holding it with this. And And then that way I can apply the epoxy and it won't unravel on me. And I can do that at a later date. I can do that. So yeah, once I let this sit for another minute or so and the glue dries, it will be set, and I can then, like I said, clip the lead coming off the spool, pull it down and tape it to the bar, right here, and then take the rod off, and then take the tape off, unscrew it from the winding rod, and, like I said, straighten the one early end, trim them so that they're same length, because that's usually handy. You're done. It's not really large. There's all the huge secrets right there. I think really this has less, how can I say, R&D information that I had to reverse engineer myself, because a lot of this is sort of straightforward, other than little things like technique that I just showed you. But overall, this is a very standard way to roll a coil, or roll whatever, a spool of enamel wire, or roll thread onto a bobbin for a sewing machine or whatever. It's the air coils that I showed you at the beginning, where you're not rolling onto a bobbin, and once you're done, you have a coil that's just wire on its own, and the little ties. How to do all that stuff, I had to just figure it out, man. And it was a lot of trial and error. I made a lot of sloppy coils until I sort of figured out the right methodology that I just showed you guys at the beginning of this. So you all now know exactly how to do those. I didn't show you the process exactly. I didn't actually show you, but I explained it to you in very specific terms and steps. So I didn't really leave anything out. It's not like I kind of told you half of it or something. That was it, man. That's all of it. So now I can sort of free this guy, because that glue is dried. It will not unravel now once I do that, which of course it will on live stream. So I just clip that with my scissors. I'm taking the end and I'm going to you can sort of put it out of your way. You can maybe wrap it around once. It helps to hold on to it. Put your tape on there. And again, I've handled that piece of tape a number of times now, so it's no longer very sticky. So I'm going to grab a new piece of tape and just put it on there. And typically I do actually remove this tape while it's still on there, because it's just easier to do while it's on there. I will also typically unscrew that screw while it's still on there. So now you can see this is free, right? I'm in here. What I'm doing is I'm using the turn crank to assist me in unscrewing that. So I'm just holding the screwdriver in place and turning the crank. Yeah, I just felt that hit the end of the screw. Now I can take that off. Screw. Coil. Gently hold those two leads together. I'm going to unravel this in a way that I'm not going to actually pull those. I'm going to try to flatten out the kinks as much as possible, and not put kinks in as I unravel that. You just pull on it, you will put kinks in it. Be careful. Also, wait till your glue fully dries, because otherwise, sometimes if there's excess, you can, if you're holding these two leads close together, you can glue the beginning of it unintentionally, and that's not what you want to do. You don't want to glue the start lead. You just wanted to glue the end lead in place. So don't do this until you've waited until the glue is fully dry. Okay, don't be impatient. And so that's a little bit long for coil leads, so I will, and again, I pulled these two together so that they're going to be the same length when I clip them. I'm going to clip the ends off a bit. Okay. There we go. So, you know, to review, if I had used the impregnating resin and was about to cook this, I would not use the glue. I would use a piece of thermal shrink wrap. Very, very wide diameter stuff. They sell it in little pieces like this. Usually you can cut with a pair of sharp scissors. And if you don't have sharp scissors, you can sharpen your scissors via these guys from Harbor Freight. They're very inexpensive. You can sharpen knives with them. They're great. Sharpening blocks are really nice. I like them. So you would fit that over like that and use your big blue dildo, or if you have a heat shrink gun, that's not a big blue dildo. Kidding. That would shrink wrap onto there perfect. That would seal that perfect, so it would look more or less like this. Hold the slack. So it would look like that. But again, that's only if you're going to use the resin and bake it. If you're going to use epoxy, that's unnecessary. Epoxy is really hard, and it will form a very hard outer shell on that and protect it not only from unraveling, but also protect it from being from having the enamel wire get, how can I say, damaged in any way, chipped, or cause shorts. If something scratches across, turns, it would short it. So there you go. I would do this for another one. I would take it downstairs and put epoxy in, and then this is ready to be installed. Something I've mentioned before, the nylon, if you use that plastic, once you wind onto here, it will splay open. So the starting diameter of that bobbin will not be the end diameter. And you try to account for that, but every single one that you machine is going to be just a little bit different when you wind it. So you want to really use a plastic that's very rigid and hard, such that when you are winding it, the walls don't start to splay out a bit, and it maintains the original thickness. And so that way it will go into a slot that it's, specifically made for. If this thing splays out, then you're going to have a real hard time in installing the coils, and you'll probably end up snapping a lead off because you're trying to jam it in. So it's very tough to do that with the nylon because of that reason. Harder plastic, or like the Bakelite original coils, the hard material, will keep its shape. Also, too, if you are cooking these, that can also deform them. So that's another reason why I like to use epoxy, because it doesn't cause them to open up any. If they do open up some, you can actually put them into a vise and very carefully squeeze them back together a bit without snapping any of the turns internally. But sometimes you don't, and sometimes you ruin the coil, right? So you don't want to be in that position. So you make these things a little bit smaller than they should be, width-wise, to account for the fact that they will splay open a little bit, much less with the Ultem, much more with the nylon. And with that, ladies and gentlemen, I think we're going to end the stream here. I pretty much have shown you everything, and you should have a real good idea now as to how to do this stuff yourself if you want to, and what to get. You want to do this stuff material-wise, and what to make, that might be helpful, like the winding rods, and how to make the bobbins and stuff, and now how to make the formless, shapeless air coils, like for the 5C. Differences between doing it with the resins or epoxy, or also every time I have said epoxy, you could also substitute dental cement, because essentially it's a form of epoxy with other things mixed in. It is epoxy, it just has other fillers basically. But you could use dental cement too. Dental cement is fast drying epoxy, so if you do that, you have to be real quick about sealing it. The slow dry epoxy is actually what I usually prefer, to be honest with you. That's what I like to use. Because again, it typically is more heat resistant. And so, yeah, I'm just cleaning up the little bits of lead that I just cut off. So thank you again for joining me. I really appreciate it. Cheers, everybody. And yeah, I'll see you all next time. So, as usual here, please do subscribe to me on YouTube. And like I said, this video will go up there as soon as I download it and get it posted up to YouTube. And so check out the whole series. It's in a playlist, and watch it all the way through. So there's still a couple of episodes left for me to do the final construction and calibration and bench tests, which is probably stuff that you'll want to see, because again, that's where the real information is. It's not this. So, if you like this video on YouTube, and dislike it if you don't like my work or me, please comment or ask questions in the comments. Again, please do subscribe. I hate to keep doing that, but be well and take care of yourselves. Most importantly, be kind to others. And I will see you all next time. Take care. Namaskar.